Hi, everyone. Welcome to Inside Out, and welcome to the Dovetail breakout room. My name is Anna. I'm one of the engineers here at Dovetail, and you've all seen Benjamin demo channels just now, and I hope you're all excited. Nice. So I've been working on the team that helped build channels, and today I want to share with you a little bit of how we did it. I'm going to try to demystify AI a little bit as well. So you've probably heard Benjamin say magic a lot in his keynote. Yeah, I did notice that as well. And as you may have guessed, magic is the moniker that we use for AI and machine learning features. And there's a good reason for it. AI and machine learning is all around us. We know it's super powerful, but it's also pretty complicated and hard to understand. So I'm going to try and break it down a bit and give you a bit of insight into some fundamental concepts that power much of today's technology. I'm going to start off with what AI isn't. So say you want to build a product. You want to build a shiny new car or an airline app or a product maybe that takes your support tickets and converts them into themes to help you get insights out of them faster. It's kind of easy to think that AI is this all-powerful algorithm that you give it your data, you tell it what to do, and it spits out the right result. But that's not really the case. AI doesn't really build complete product solutions yet. Rather than being a whole car, it's more like a collection of car parts. Each part has its own specialization and is really good at what it does, and that's a machine learning algorithm. And it is up to the engineers to put them all together in a way that makes sense, and in a way that builds the product that will bring value to your customers. So first of all, let's get through the quick difference between machine learning and generative AI. You would have heard both of those terms pretty often, I'm sure, and they can be used interchangeably sometimes. But the key difference is in what they focus on. So machine learning finds patterns in existing data and applies them to new data to generate predictions. So, for example, machine learning algorithms focus on giving you music recommendations or looking for the best search results for you. On the other hand, generative AI is what every billboard in San Francisco refers to when you see AI on it. Yeah, it still uses the core machine learning algorithms, but it focuses on creating new data. Something like a school report or a travel itinerary or editing an image. So let's break it down. Now, as an engineer on channels, that's what I'm most interested in, and that's what I'm going to use as an example. You all saw Benjamin's demo, but let's just go through what channels is once more. We take your data, support tickets, NPS feedback, or product reviews, and we extract themes out of it. We let you look at how these themes change over time, and we let you see a quick summary of a theme, as well as dig into individual data points. And we do that continuously. When new data comes in from front or intercom, it will go into your channel. So first off, we start with your data. It's kind of like a box of mixed Legos. They're all different shapes and sizes. There's not much pattern to it. That data isn't really that useful. I mean, it is, but if you can't see patterns, it doesn't really make sense. And our job, the job of channels, is to help you make sense of it. So how do we do it? Before we can do anything to a piece of data, we need to translate it to a language that a machine learning algorithm can understand. Let's look at this Lego piece. It has a few key characteristics. In this case, it's just shape and size. But in reality, a piece of data can be a few lines of text or a whole paragraph. We need to figure out how to encode those key characteristics in a way that an algorithm can understand. That's called generating an embedding. So how do we actually do it? So looking at a Lego piece, we have a Lego piece will have size and color. So we'll create a two-dimensional space where each axis is, one axis is the size, the other axis is the color. And we'll place the Lego piece in that two-dimensional space. Now, again, text is much more complicated than Lego. So instead of a two-dimensional space, you will end up with something multidimensional that is very hard to visualize. But the core concept is the same. You place a piece of data in a space to be able to compare it with other pieces. And you use those coordinates of where that piece is located to then pass it to other algorithms to do useful stuff with that data. So yeah, knowing where a piece of data is by itself is not useful. But what it allows us to do is to look and compare pieces of data and split them into buckets. This is called clustering, which is another machine learning problem that's pretty common. It looks kind of something like this. You have your multidimensional space, and you have your pieces of data floating around. The job of a clustering algorithm is to find pieces that are close together. And there are many, many parameters that you can use to tweak and pick the right algorithm for the job. And that is what us engineers do. We'll test a bunch of different algorithms and pick the right one for the task. So what does that mean in practice? In practice, that lets us extract themes from your data. So, however, at that point, they're not particularly useful because we don't actually know what's in the theme. Think of it as an unlabeled box of Lego pieces. You don't really know what's in it, and you have to go through all of them to figure out the value and what you can do with them. So next is we need to summarize the themes and actually label those boxes. This is where generative AI comes in. This is where you can ask ChatGPT to give you a summary of a theme. We take all the data points, take all of those vectors that we created, send it to ChatGPT, and ask it to give us a summary. Once we have the summary, we can actually tell you what's in a given theme and help you make sense of it. I feel like that's pretty neat. But there's one final piece of the puzzle missing. What do we do with new data? When new data comes in, we need to figure out which theme it belongs to. This is another core machine learning problem called classification. And classification algorithms are quite similar to clustering in a way. They still look at where the data is in space and figure out how to place it in the right bucket. Same as with clustering algorithms, engineers will spend a whole bunch of time evaluating different classifiers and seeing how they work for your data. Now, that is what lets us put updates into the channel. So when a new data piece comes in from front or intercom, we know where it goes. All right, so hopefully that gave you a better idea of how channels work. We take your data, we cluster it, we then summarize what's in the clusters to give you themes that are useful, and then we classify new data when it comes in. Obviously, this is a very high-level description of what channels does, and there's much more under the hood. But I hope that gives you a little bit of insight into how AI works and also how channels work specifically. And speaking of learnings, I wanted to share some learnings we had when building channels. The first one was to stay pragmatic. Staying pragmatic is like the sixth unofficial value of Dovetail. And we take it pretty seriously. It was really important for us in the channels team to build the product in a way that we can get it to customers' hands as soon as possible. And also make it flexible so that we can swap out all of these algorithms under the hood without changing your experience massively. Why was that important? There is a very common issue with using algorithms and machine learning, which is overtraining it to a specific set of data. Say, for example, we've trained it on our sample data set, and it works great. But then customers start using it, and it actually doesn't make sense. It's not that good at figuring out different types of data. So, yeah, hopefully channels right now allows us to swap out different algorithms without affecting your experience. The next one is listening to your customers. I know, I'm sorry, this is cringy and very, very obvious. You're already in this room. You already know that you have to listen to your customers. However, I'd like to share a learning from channels that we had. When we built it initially, the experience mapped really well to an engineer's understanding of what channels looks like. So to us, it made perfect sense. But as soon as we got it into customers' hand via our private alpha, we started getting feedback that it was just too convoluted, too many steps, too complicated. So we went and simplified it, and this is the channels that you see now, which hopefully is a better experience for everyone involved. And the final learning was to keep learning. Again, you're here. I don't really need to tell you how fast AI is moving. You see it pop up almost overnight within a year. And as engineers and as product designers, everyone in this room, we sort of have to keep track of the changes that pop up to stay ahead of the curve and actually provide good experiences. So as an example, in the last few weeks, our team in Sydney has almost changed the underlying model of channels entirely, again, without really changing the user experience. But that's something that's going to let us have better themes and also make it easier to build channels. Cool. So the final takeaway is one day AI might provide complete product solutions, and you just need to tell it what to do. But that day is not there yet, and our jobs are still our jobs, thankfully. And until then, it is up to us, the product engineers, product designers, everyone who works in product, to figure out how to use those AI algorithms that are car parts to build the product that our customers actually want to use. Cool. And if you're curious to know more about channels, just ask me. I'll be around all day. And also, sign up for the channels waitlist, and I'm going to answer the question now. Question from Nicole. For more complex spaces like internal-facing products, will we be able to help train the channel's algorithms in any way? I've often found Dovetail features work better for commercial customer-facing products. It's a really, really good question. So Benjamin mentioned in his keynote the human-in-the-middle approach that we take with all of our AI-powered features. Channels does do that as well. I didn't really go into it in the interest of time, but the idea would be you can move data points between different themes, and our classifier will learn based on the data points you moved. Now, it's not exactly, a classifier is not an LLM, so we're not training an LLM on your data, just to be super, super clear, but we are going to get better results because the content of those buckets will be more accurate. And so a classifier can better tell which bucket a piece of data belongs in. Does that answer the question? Yeah. Cool. Awesome. Thank you for your time, everyone, and enjoy the rest of the conference.